Hi, in today's lesson we're going to continue on with our exploration of derivative rules, and we're going to start with a do now problem here. Y equal to 3x squared times the quantity x cubed minus 7x squared plus 8. Find dy dx. So why don't you take a couple minutes, pause the video, find that derivative, and when you're ready restart the video and we'll go through the derivative together. If you're continuing on here, I'll assume that you have successfully attempted the first derivative of this function. So when I look at this, I'm thinking I've got 3x squared times the quantity x cubed minus 7x squared plus 8 for my y function. Well, that's equivalent to y equal to 3x to the 5th minus 21x to the 4th plus 24x squared. And so I know from my power rules that we talked about last time, when I'm taking my derivative, the derivative of 3x to the 5th is going to be 15x to the 4th. The derivative of negative 21x to the 4th is going to be negative 84x to the 3rd. And the derivative of 24x squared is going to give me 48x. So there's the answer to the do now. Dy dx equal to 15x to the 4th minus 84x cubed plus 48x. That function represents the derivative of the original. It represents the slopes of the tangent lines at each point on the original function. Now, when I look at that original function, I had another thought, and I was thinking, well, what if I could just take the derivatives of the individual pieces and then multiply them together? So let's try that. And if I try that, I get dy dx equal to, let's see, the derivative of 3x squared is 6x. And the derivative of x cubed minus 7x squared plus 8 is going to give me 3x squared minus 14x plus 0 because of the constant 8. And when I simplify that, clean it up a little bit, I get 18x cubed minus 84x squared. Oh dear. Not what we got the first time. So unfortunately, the model of the story is that the product, or excuse me, the derivative of a product is not equal to the product of the derivatives. But there is a way that I can deal with products other than just multiplying everything out, because sometimes that's not a viable option. Sometimes the multiplication would be too complex. So let's take a look at what's known as the product rule for derivatives. And the product rule for derivatives says that if I have a function y that's made up of the product of two individual functions f and g, then when I go to take the derivative of y, I can find it by taking my original function f and multiplying it by the derivative of g, and then adding on the original function g and multiplying that by the derivative of f. Sometimes I like to think of this as my first function, f, multiplied by the derivative of the second function, g, and then add on the second function, g, and multiply that by the derivative of the first function, f. First times the derivative of the second plus second times the derivative of the first. So let's see how this plays out, and we'll go back to our do now problem to try it out. So I've got the same problem. This time I want to use the product rule. So I'm going to think of this as y equal to f times g, where f and g are implied to be functions of x. So dy dx according to the product rule is f times g prime plus g times f prime. Oh, excuse me. Let's see how that works out with this one here. So I'm going to call my first function here f. So 3x squared is my f function, and my second function here is going to be my g. So x cubed minus 7x squared plus 8 is going to be g. So when I follow the product rule, dy dx says I'm going to take my first function f as is, 3x squared, and multiply that by the derivative of g. Well, the derivative of g is 3x squared minus 14x plus 0. So just 3x squared minus 14x. Now I need to add on g as is, so x cubed minus 7x squared plus 8, and multiply that by the derivative of f, and the derivative of f is going to be 6x. Now that looks nothing like the derivative that we got just a few minutes ago, but I'm going to multiply it out and just see what happens. So 3x squared times 3x squared, I've got 9x to the 4th minus 42x cubed plus, distributing the 6x, 6x to the 4th minus 42x cubed plus 48x. And when I clean that up, looks like I have 15x to the 4th minus 84x cubed plus 48x. So there's my first derivative. And let's just go back and check to see if it's what we got. And here we go. 15x to the 4th minus 84x cubed plus 48x is exactly what we just got by using this product rule for derivatives. Now, since the derivative of a product is not equal to the product of the derivatives, I don't think there's much chance, if I have a quotient, f of x divided by g of x, that the derivative will just be the derivative of the individual pieces there. And as it turns out, it's not. So we have what's known as the quotient rule for derivatives. If y is equal to f of x divided by g of x, then g of x is equal, then dy dx is equal to g times the derivative of f minus f times the derivative of g. Sorry, that should be a derivative. All divided by g of x squared. Another way to think of it is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all divided by the denominator squared. So, bottom times the derivative of the top minus top times the derivative of the bottom, all over the bottom squared. Denominator times the derivative of the numerator minus numerator times the derivative of the denominator, all over the denominator squared. G times f prime minus f times g prime, all over g squared. And let's just see an example of how this works. So if I have y equal to 3x squared minus 8x plus 5 divided by x cubed minus 7x. If I treat this as f over g, where f then is my numerator function and g is my denominator, then dy dx is equal to g times f prime minus f times g prime all over g squared. And seeing how this plays out, dy dx will be equal to the denominator, x cubed minus 7x, multiplied by the derivative of the numerator, 6x minus 8, minus the numerator, 3x squared minus 8x plus 5, times the derivative of the denominator, 3x squared minus 7. All of that divided by the denominator, x cubed minus 7x, raised to the second power. So, g times f prime minus f times g prime, all divided by g squared. Quotient rule, there's my derivative. Now, it's not in the best looking shape, but if I were to multiply everything out and combine like terms and everything, I'd have a much simpler rational function to work from. However, right now, this is a derivative. And unless I need to clean it up, I don't have to, because I have a derivative right now as that stands. There are going to be some cases where we do some cleaning up, multiplying in by monomials, little things that we'll get to later. But using the rules, this is the derivative of the function, the rational function that was given to us originally, and that's what we needed. Okay, so you're going to try some practice problems with some products and quotients, see how they go, and that's it for now. Bye.